So in this section, we're going to use the solubility rules from part 4 and apply them to determine whether compounds are soluble or not. Before we apply solubility rules, let's just look at some of the rules from page 15. These ions are always soluble in water. For instance, nitrate is always soluble with any cation. So potassium nitrate, sodium nitrate, ammonium nitrate, those compounds are always soluble in water. When you talk about the alkali metals in the second box there, we mean everything in that first column, column 1A. Potassium, lithium, sodium, those ions are always soluble as well. Then there are some ions that are generally soluble except with a few ions. And so for instance, the halogens, chlorine, bromine, iodine, fluorine, are soluble except with these ions. So magnesium chloride is soluble, but silver, lead, or mercury chloride is not soluble, is insoluble. Sulfate, same rule, generally soluble except with this list of ions. Now, you used to have to memorize the solubility rules over the summer for AP Chemistry, but in the new exam, they're telling us that you don't have to do that. So we're assuming that they will give you a solubility table like you have in your packet on page 15. We'll find out more at the workshops in the summer. Some ions are generally insoluble with a few exceptions, and so most hydroxides do not dissolve in water. They're insoluble except for these 3 ions, and you have to include the alkali metals from the top of the list that were always soluble, and ammonium. But other than those cases, hydroxide would generally be insoluble. Same thing with these ions. They are generally insoluble except again with the alkali metals and ammonium. Acids are included on this list because some acids are able to be pulled apart by water even though they are covalent compounds to begin with, like we talked about back in the naming acid section. When HCl goes in water, this is a polar bond. Chlorine has a higher electronegativity. The electron in the bonds are pulled closer to chlorine, so when the bond breaks, you end up with H plus and Cl minus. And we said back in the naming acid section that's called an ionization reaction because you produce ions. So there are 6 ions that water is able to break that bond and form H plus and then some negative ion, and that would be these 6 right here. Everything else that's an acid, and acids start with an H, are insoluble acids, and they will not break apart in water. So really only those 6 ions that are listed on this section are soluble acids. The first rule on page 16 asks you to determine whether the compound potassium chloride is soluble or insoluble. There are 2 rules you could use back on page 15 on your solubility list. Alkali metals are always soluble, so K plus 1 is always soluble. It doesn't matter what the negative ion is, K plus 1 will be a soluble compound. And so just tell me it's soluble, and what that means is the water can pull apart the 2 ions. And so what ions would there actually be in the solution? It would be K plus 1 and Cl minus 1, and then you would also have some water present. So I just want you to tell me what ions are present. Another rule that you could have used to determine this compound's solubility is the rule about chloride ions being soluble except with these 3. So with anything else it would be soluble, and so you could just use that rule to determine that KCl is soluble. But you only have to find the solubility on one of the ions. If one of the ions is soluble, it doesn't matter what the other ion is, the other charged ion, the whole compound is soluble. The next compound, copper nitrate, you can use the nitrate rule from page 15, that nitrate is always soluble, and so this compound will be dissolved by water. Now you do need to, when you give the ions present, know the charge on the copper, and so we can work it backwards from the charge that we know of the 2 nitrates. That's -2 charge, so the copper must be +2. So you really only have to list one of each of the ions. We don't want to leave the parentheses around the nitrates. We just want to list which 2 ions are present in solution. We're not concerned with how many ions at this point. Compound silver chloride, you don't have a rule on page 15 for silver solubility, but you do have one for chloride. So chlorine is soluble except with 3 ions, and silver is one of those ions, and so this compound would be insoluble. And when I ask you what ions are present, because this compound does not dissolve, you don't have silver and chloride ions, so you're just going to tell me none. You have the water, and you have the insoluble solid sitting there, the silver chloride in the water. Now we do know that water, if you remember from pH in first year, water has a little bit of hydronium and hydroxide ions that we talked about pH, but in this case we're just talking about the compound that we're focused on. The compound zinc hydroxide, you don't have a rule on page 15 for zinc, but you do have one for the hydroxide ion. So it's generally insoluble except with these three ions and the ions, positive ions that are always soluble, like ammonium and the alkali metals. So in this case, we're going to decide that this compound is insoluble, and what ions are present in solution. You would say none. The zinc and the hydroxide stay together in that ionic crystal that's solid, and water does not dissolve it. So now on page 17, if you'll just go through this list of compounds, decide soluble or not, tell me what ions are present in solution. If the compound is soluble, you're going to list the one positive ion and one of the negative ions. You don't have to tell how many of each ion. If the compound is insoluble, you're just going to tell me none, that there are no ions from that solid present in solution.